okay, because we have we must have selected this slope in the pipe creation itself, or you can change slope at different points of the pipe. For example, you started the slope of 1:100, and after a few meters of pipe you change the slope to 1:200, and so every component you can change the slope. Okay, it will automatically calculate the required angle for the leave point once you select the current slope. Okay, you can also start the slope from nozzle. Not really nozzle, because it will practically the side at side the slope will begin from after weld neck flange, because the flange is a rigid component, so it cannot itself go into slope. What they do at site is they connect the pipe and trim the pipe little bit from this position. So earlier in PDMS it was not possible, in 11.6 it was not possible to give the slope after flange or T. You have to use zero radius bend to give the slope. But now, without use of zero radius bends also, you can create slope after rigid components like T, even flanges, reducers, because the P point of the those catalog has been updated. Okay, so the condition for P points is given. This should be followed in catalog, and also this is there in the piping catalogs manual, piping catalog and specification manual. This should be complied with if you want slope after rigid components. Okay, similarly, it is for, in case of T, vertical leg. So if it is a vertical leg, suppose this is falling vertically from up to down, and the branch requires a slope from this point. So slope down needs to set. Okay, so when you select slope down, this will be icon. I told you this is the icon for slope down over here. See, so while component T creation, you have to select, when you select this slope down, it will direct the P3 point, not the leave point. For other components, it will direct the leave point in that direction. But for case of T, and T is vertical, not on horizontal line. So the slope will be directed to the P3 point. So this does not affect the direction value in the text box, because this is related to P2, but it can be seen that branch value has changed. So we'll see. And when the T is on a sloped line already, okay, so by default the P3 of the sloping tile will be angled. That means there are some cases where this is a, say, flare line is going and it goes into slope, but the branch falling on top of the T needs to be vertical. So by default, if the header line is in slope, the T will also, the third point of the P will also be at some angle, but it can be made vertical. Uh, this slope can be removed by setting the slope mode and clicking up or down. Okay, so we'll see this. We'll create some example of this. I guess most of the uh, industry need to make use of it. You can see after you press up, initially it was at angle. See, the label is showing here east 88.585 degree, but when you press up with the slope down button, it can be made vertical. Okay, fine. So let us create an example. So this is 100C16 pipe, and you have to model it in. Let's create this. Let's follow this example, and then we will create some arbitrary example also, not as per your requirement. So 100C F1C is the spec, 100 mm 50 degrees Celsius, 1:100. This is important. This we have to supply initially. So this is we are taking when the pipe has to be given slope from the initial point itself. Okay, and it is connected to E130 NS2. This is the and open end. This is a tail. Okay, fine. So sorry, 100 C 16. So go to your piping zone. Go to create pipe functionality. Sorry, let me close it. 100-C-16. Select the spec F1C. 4 is 100. 50 degrees Celsius temperature. And over here we have to give 1:100 slope. Okay. This will be carried same to the branch also. Apply it. Okay. Head is to be connected to E1302A NS2. So let's add that equipment. You can type it here. E1302A. Sorry. So you can pick to connect to, you can click anywhere on equipment and later on check where is the NS2 nozzle. Okay, so this is the bottom nozzle. You can click on connect, right? Okay, it creates a head component. So let it be it will create slip on flange. So let it be there. And on the tail side, this is the coordinate. Use slope up. So on the tail side, we have to this end. We have to use slope up functionality, and that slope will be 1:100 only. So west 303,000. Let's copy this coordinate. 303,000 106434. Up direction west. From here, the slope by default it is slope down. Make it slope up. So it will change as per you make it up or down. It will change the direction here. Make it open end. Slope up. Okay, so it will take from the initial direction, whatever direction you specify. So it is see. So it tilts down or up. So there is little difference. If I make it no slope, it exactly makes west. Up. Right. Let's check the information again and click on apply. Okay, so this is how it looks like. There's a fall of 1:100 in the whole line. Now connect a well neck flange. Okay, it's a well neck flange, so we'll convert it to well neck and then create a elbow and give a 1000 mm from the flange. So distance of 1000 mm from the flange. And from here, from this